In this lecture, we are going to discuss about how the different output devices like CRT, LED, LCD are interfaced with 8051 microcontroller. The, as we know that the LED 7-segment display interfacing with 8051 that can be used to show the result. So that's why we call this 7-segment display device as the output device. So basically we choose the device according to the size of the data. The firstly the cathode ray tube. The cathode ray tube used to show the large amount of data such as graphs, trends, alphanumeric information. Such information we can show with the help of the CRT. Next output device is LCD, that is liquid crystal display, which is an low power portable instruments and rarely used in industrial application for display purpose. And next device is LED, that is light emitting diode, that displays are bright and strong and widely used in industrial display, but the LED displays only the numbers. So this diagram shows how the 7 LEDs are arranged and the numeric data can be displayed. So for that purpose the 7 LEDs are arranged in 8 shapes, as you can observe in the diagram, like A, B, C, D, E, F, G. So here 7 LEDs are arranged by using the 8 shape, and one more LED is used, and it is act as the display point. And all these LEDs are connected to the 8051 ports. But according to the connection, these two LED display are classified into two types, that is the common anode LED display and common cathode LED display. So as you can observe this first diagram, that containing the anodes of all LEDs are connected with the VCC, that is common connected to the VCC. So that's why we call it as the common anode LED display. Then in another type of connection, the all cathodes of all LEDs are connected to the common, so that's why we call it as the common cathode LED display. So this next diagram shows the how 8051 microcontroller and the 7-segment LED display are connected. The 8051 microcontroller port 1 containing 8 pins through the register, the LED 7-segment display is connected. So as we know that while displaying the result or the data by using the 7-segment LED or any other display device, the pulses or the time required or time clocks are generated through the xtal 1 and xtal 2, because there is the oscillator is connected and having oscillator frequency is 11.0592 microhertz. So in this way the LED 7-segment display is connected to the 8051 microcontroller. Next interfacing device is LCD, that interface with 8051. As you can observe this diagram, the VCC pin of LCD is connected to the plus 5 volt and VSS pin is grounded. One more pin is VEE, that control the contrast of the LCD, and all data pins of LCD, that is from D0 to D7, all are connected to the port 1 of 8051 microcontroller, and port 2 of microcontroller is connected to the RS pin. RS pin is the register select that contain the two register to control the LCD, that is the command port register and data send register. So RS pin is connected to the P20 and P21 pin is connected to read write, and P2.2 is connected to the E. So in this way all the uh, port 1 and port 2 pins are connected to the LCD, and through the data pins the data is captured from 8051 microcontroller port P1. So when the RS pin is 0, so at that time the instruction command code register is selected, and this register allows to send the commands onto the LCD. The commands like clear display, cursor at home, cursor on next line, cursor moving from right to the left. So again initializing the display. So such commands we can send with the help of the instruction command code register. But how this register is selected? So when the 0 signal is present on RS pin, so at that time instruction command code register is selected, and once this register is selected, such commands we can send onto the LCD. When RS is 1, so at that time the data register is selected, and this register helps to the user to send the data to be displayed onto the LCD. Another pin, that is the read write, when it is 1, then it allows to read data from LCD, and when it is 0, then it allows to write data onto the LCD. Sometimes the read write pin is connected to the ground. So again, this is another diagram that shows the LCD interface with 8051 microcontroller. One more pin present on the LCD, that is the enable pin, that used by LCD to latch information presented to data pins. When data is supplied through the port 1 onto the D0 to D7 pin of LCD, the pulse is required, that is we make this pulse high to low pulse and must be applied to this pin in order for the LCD to latch the data or the information that we want to present it or display onto the LCD. Next, how the keyboard is interfaced with 8051 microcontroller. So as we know that the keyboard is an input device, through this we can take the input. So here we are going to discuss about how keyboard input device is interfaced with 8051 microcontroller. The keyboard is organized in a matrix of rows and columns, and CPU can access these rows and columns through the ports. So there are two type of ports are used. So one port is act as the output and another port is act as the input. So 8 by 8 matrix of keys can be connected to the microcontroller. When a key is pressed, the rows and columns make contact, otherwise not. Means that is the indication when rows and columns get contacted, then there is key is pressed, and the one program that always scan this keyboard and observes which key is pressed and accordingly send that key data to the microprocessor or microcontroller for further processing. Microcontroller takes care of the hardware and software interfacing of the keyboard. So this program that always scan this key press is stored on the EPROM of microcontroller, and it always scans the keys pressed continuously and identifies the which key is pressed and present it to the motherboard. So here is mechanism by which 8051 scans and identifies the key. So this figure shows the 4 by 4 matrix connected to the two ports. This one is the first port, and this port 1 act as the output, and this one is the port 2 act as the input, and this columns of keyboard, here 4 columns and 4 rows. 4 rows are connected to the port 1 and 4 columns are connected to the port 2. So these 4 columns are connected to the again VCC, and this 4 rows are grounded. So rows connected to the output port and columns connected to the input ports. If no one key has pressed, the input port will else once for all columns as they are connected to the high VCC. If all rows grounded and any one key is pressed, then there is contact between this column and the rows. So at that time the value of that column is changed to the 0 since the key is pressed provides the path to the ground. So this is the connection diagram of 4x4 rows 4x4 keyboard. So microcontroller continuously scan the keyboard to detect and identify the key press. So here steps are given for valid detection of key. So already I told you the keyboard is scanned for key press with the help of one program. That program is stored in the EPROM. When key press is detected, the program calls delay routine of 20 milliseconds, and after 20 milliseconds again key status is checked. If it is found to be pressed, then step 4 is followed, otherwise go back to the step 1. Then in the fourth step key entry is accepted and such information is provided to the microcontroller for further processing.